Question 4. Propanoic acid is a weak acid. Acid dissociation Ka is that 25 degrees Celsius. State the meaning of the term weak acid. Weak acid partially or slightly dissociates / ionizes, dissociates in water to form H plus ions. Partially weak acid, acid that's partially or slightly ionizes / dissociates in water to form H plus ions. Given expression for the acid dissociation constant for propanoic acid, it's going to be H plus H plus C2H5COO minus over propanoic acid C2H5COOH. H plus C2H5COO minus over C2H5COOH. 4.3, 4.4, and that's it. It's 4.3. Shouldn't dilute that much of propanoic acid. Total volume is that. Calculate pH. So first things first, let's work out the moles of C2H5COOH propanoic acid, which is what? No 0.125 mole per dm minus cubed. Then it says calculate pH. So we know pH equals minus log 10 of H plus. So therefore we need to find H plus in order to find the pH. How do we find H plus? Well, we know this is Ka. Well, Ka, we rearrange this equation. Let's rearrange it. We get H plus equals propanoic acid C2H5COOH times by Ka divided by C2H5COO minus. But what we can do is we can say that H plus equals we get this, but instead of dividing by C2H5COO minus, which we don't know, we can just say H plus squared is equal to this. So yeah, another thing you need to know. So now we've got H plus squared is equal to this, therefore H plus is equal to square root of C2H5COOH, which is 0.125. We found out the moles of that in the beginning, times by Ka, which is here. 1.3 times by 1.3 times by 10 to the power minus 5. Okay. square root 0.125 times by 1.35 times by 10 to the power minus 5. We get this is equal to, the answer is equal to 1.299 times by 10 to the power minus 3. Therefore, pH equals minus log 10H plus. pH is equal to minus log 10 of 1.299 times by 10 to the power minus 3. pH is equal to 2.89. Perfect. And then 4.4. A buffer solution with the pH of that is made by dissolving X grams of sodium propanoate in a solution of propanoic acid. The final volume of the buffer solution is 500 centimeters cubed, and the final concentration is that. So first things first, let's find out the amount of H plus. We know H plus, this equation, is equal to 10 to the power minus pH. Therefore, H plus, we were given pH in the question, is equal to 10 to the power minus 4.50, which is equal to 3.16 times by 10 to the power minus 5. Okay, now let's rearrange the equation. So what do we need to find? Sodium propanoate, and we know the final volume of, let's find out the, what's it called, the concentration of sodium propanoate. So we know Ka equals H plus C2H5 COO minus over C2H5 COOH. C2H5 COOH. Don't get confused. Oh, but it's got an Na. We don't care about that though. We really don't. We want, we don't need to add that into the equation. So now we're going to rearrange it, and we'll get, well, what we're trying to find. We're trying to find a sodium propanoate. So we're trying to find this really. So we're going to get C2H5 COO minus is equal to Ka times by this C2H5 COOH divided by H plus. And look what we have here. Do we have C2H5 COOH? Yes, we do. There we go. Do we have H plus? Yes, we do. We just worked it out right just before. And do we have Ka? Yep, we do. So we can just substitute the values in. H5 COO minus is equal to Ka 1.35 times by 10 to the power minus 5 times by C2H5COOH, which we know in the question is 0.250, divided by H plus, which is 3.16 times by 10 to the power minus 5. And I'm gonna, the next time I do my chemistry exam, because I've done my mocks in chemistry, I've got next mocks in February, but I'm gonna bring a highlighter to the exam. And when you get to these like really wordy maths questions, involves equations, finding x, 6 marks, then highlighting it is going to probably ensure you get an extra mark. because we know now, just by underlining it, that's given in the question. Propanoic acid, concentration of it is given in the question. So 1.35 times by 10 to the power minus 5 times by 0.250 divided by 3.16 times by 10 to the power minus 5, we get, I don't know what's going on, we get 0.1068. Are we done? No, because this is the concentration, right? And we're trying to find the mass of something. So we need to find the moles of this. So the moles are going to be 0.1068 times by the volume, which is 500. Yep, but obviously we need to have moles per the minus cube, so divide by 1000. And 500 divided by 1000 is, well, just write as that. It's 0.5, but it doesn't really matter. We get 0.0534. And how do we find the mass? Well, we know, I don't write this. We know moles is equal to mass over mR. Therefore, the mass is going to be mass is equal to moles times by mR, which is going to be 0.0534 times by the mR of this, which it doesn't give in the question. It's a bit of a bummer, a bit annoying. But the mR of that is 96. Sodium propanoate 96. So we're timesing the moles by 96. So my 0.0534 times by 96, and you get 5.1264, 5.1264, which is 5.13. Using the figures up to 2 decimal places. That is the end of question 4.